Do you see my whiteboard?
Yes, Professor.
Cool. Okay. This, if you want, I send this packet, but no, it's very similar to the final. Not exactly, but as I want to solving any question. I don't know if we finish or not today. You know, we continue on Monday, que es the last day. Okay, question one say 25 x squared plus y squared minus 350x plus 1200 equals 0. You identify immediately that this belong to the ellipse. How do you know that? Well, you have x squared and y squared. I don't care the coefficient. The coefficient is totally irrelevant to identification. And plus in between. Parabola is x squared y no square or y square x no square. This is parabola. And hyperbola is similar, but this minus no plus. So this also exists x square exists y square, but it's minus. I don't know, see here or here, depending on the problem. So one positive, one negative. No? Maybe this is positive and this is negative, or this is negative and this is positive. This is hyperbola. Entonces es obvio que es elixir, right? Es elixir. The problem is que this elixir is expressed in general form. It's confusing, very. I need to express it, I need to manipulate in another equivalent expression in standard, que maybe is like that. X minus h squared divided by a squared plus y minus k squared or b squared equal 1. So right hand side must be 1, and you complete the square in order to get the parenthesis nice and the square. Actually, we have not only this equation, we have the option que es b squared and a squared. Remember, in the elixir, the most important thing is a is the big. So a is greater than b. Si the big is associated with the x, okay, no problem. I know that my elixir look like that. Si the big is associated with the y, my elixir look like that. I don't know. To find that, we need to manipulate and convert this to a standard. This is the classical standard. Standard form. And this is no. This is called a general. General. Okay, what is the procedure? Okay, the procedure is easy. The procedure, you separate the x part. Look, x part, x part. And y part, well, y part we have only one. No, so we have no y linear, it's degree 1. We have x, yes, we have this square and this linear. But okay, no problem. I put 25 x squared minus 350. X. Immediately, I want to analyze if it's possible or no. See, is there common factor in between 25 and 350? This is easy because you take 350, you put in your calculator, and divide it by 25. And the answer is 14. So in your calculator, you copy 350, the sign is not important, or 25 is 14. Okay, so I take advantage of this. So new factorization, 25, common factor, parenthesis, x squared minus 14, x plus the magic number that completes the square. And the y part, no, because the y part no have no linear, entonces es just y squared. Entonces always the coefficients without variable, I move to the right. And you have another box in order to keep the equilibrium of the our equation. It's obvious that you take b gets 14, it doesn't matter the sign, divided by 2 gets 7, and you square. At 49. And 49 is the magic number that I put here inside this box. Okay, when you are doing this action, I guarantee you 100%. Okay, our trinomial is perfect square. If you put artificially 49, well, you need to put one other number, okay, not necessarily 49, because remember, 49 is inside one parenthesis, it's multiplied by 25. And actually, you multiply 25, multiplication 49, and the answer is 1225. And this is the number I put in the right hand side in order to keep the equilibrium of the equation. 1225. Where come from 1205 was the multiplication 25 times 49. Okay, almost we finish. Now I know very well that this trinomial is perfect square and the factorization is x minus 7 squared. Where come from 7? It's square root 49. Now, what is the reason it's minus? It's because this sign is minus. Because this sign always must be positive. Plus y squared, and you subtracting here gets 25. Okay, remember, right hand side must be 1. You divide the whole thing by 25. 25, 25, 25. 25. So my new equation in standard nice is x minus 7 squared plus y squared over 25 equal 1. Bam! Super cool. And this is the beginning now. The rest was stupid algebra. It helped me to convert from general to standard. Okay. So my first question is, what is the center of this helix? Remember, the center in any helix in standard is h, k. In our specific example, the center is located at the point 7, 0. Remember, opposite sign, guys. You see in the equation, minus is because in the point is positive. And y is 0 because we have no minus nothing here. Y is have no translation. Okay. Now, who is this a squared and who is b squared? It's obvious that a squared is the bigger, and the bigger is 25. And b squared is 1, by the way, it's invisible one here. Okay, therefore a is 5, and b is 1. Okay, so now remember one more time, the major axis is parallel to the y-axis. Big 25 is associated with the y, therefore our helix, I suppose, can look like that. Yes? This segment would be at A, in our example 5. This is the center. This segment is 5 in another direction. This segment is 1 in that direction and 1 in that direction. Okay, you the vertex and co-vertex. We are doing detail now. Okay, after we check it, double check in decimals. I want to find more. I want to find C. Remember, the formula for C is C squared is equal a squared minus b squared. Because c squared is equal to 25 minus 1 is 24. Therefore, c alone is square root 24. We put in a calculator is 4.899 approximately, using 3 decimal places. Okay, with this information, we are ready to plot the points, but we are doing directly in decimals, no, to save time. I have roughly idea like that. However, I want to do it in decimals. I sent today one link connected with the script of Desmos I created for my students for the conic section. Let's call it conic section. If you want to open now, in order to follow me. Okay, let me try to share the screen. Sorry. Now Desmos over there. If you want, no, you watch it only, but it would be good, in my opinion, okay, you are doing simultaneous with me, no? Okay, entonces, en our example, A5, you copy here. Do you see Desmond? Yes or no? Answer me. Let me see how many students we have now. Oh, Daniel, Patrick, Nata, Anthony, Isabella. Aileen, and the rest. I'm Mia. Wow, Mia. Okay. I explained, I sent email today, okay, after the 25th, so Wednesday is 26th, I close everything. So you forgot to send me something, zero, I put zero, right? Okay. So now, answer me, you see this or not yet?
Yes.
Yes. Okay. You open your own computer or no? No? No, see, it's complicated, no. Only watch me. I try. So you copy AFI, B1, sé cuál dice this. But H and K is 7 and 0. So H is 7, positive, of course. And K is 0. Forget about P. P is for the parabola. And the elixir, we need to set up only A, B, H, and K. And I categorize my example, my parabola, my elixir, sorry, like a vertical, no? Because on the paper I analyze is vertical elixir. Boom, look at that. Conclusion, center, located at the point 7, 0, this is center. The vertex 7,5 and 7,-5. Co-vertex 8,0, 6,0 because they're from 7, one distance to the right and one distance to the left. That's all. And the focus is almost close to the vertex. You see? Because the eccentricity of this elixir is almost 1. So we have one parameter that is called eccentricity. Eccentricity is the division, C is the focal distance, divided by A. I guess it's semi-major axis. Entonces, they are very, very close. So when you divide 4.899 divided by 5, of course, you get the number less than 1, but it's close to 1. That indicates us that our elixir is too narrow, too flat. Si es 0, es circle, it's rounded. But it's not rounded. It's extremely flat. Do you have a question? No? Come on, guy. This is a moment to take advantage with me and your friend, no? I need to get you understand and you get good grade, no? Yes or no? Let me come back again to the whiteboard.
Yes, I understand.
I understand, cool. Okay, let's go back to the whiteboard. Switching to whiteboard. Do you see whiteboard? Let me erase only the part of that question. Okay, delete. Let me try to erase by hand that part and that part. Okay, let's move on to question 2. Question 2 is easy. Question 2 is y minus 3 square equal 4 paréntesis x plus 4. Entonces this is already expressed in standard because the formula for the parabola in standard is y minus k squared equal 4b x minus h. Look like similar, right? Very, very similar. So the vertex of this parabola is located at the point -4, +3. Okay, this h is this, but opposite side. Remember, you see positive in the given equation. However, in standard, I suppose it's negative. And the reason it's opposite is because h value is -4 and double negative becomes positive. However, in K, no. In K is +3. That is relatively easy. Memorize que it's opposite sign in the point and the equation. And one more, I see que 4p is 4. So it's a coincidence. 4p is 4 is the reason que p is 1. Si p is 1, we are working with the parabola horizontal open to the right. So our parabola look like that. At this point, get the vertex is the point -4, 3. The rest, let me try to do, but it's easy. The focus is p distant. P is 1 in our example. Okay, entonces es 1. Entonces this is the focus. This is the vertex. This is the focus. Distance 1 here. I suppose using my common sense que the focus is at the point -3,3, no? So you moving horizontal. When you move horizontal, you affect the x component. The y component stays the same. Es 1, entonces es -4 plus 1 because you move to the right, it's plus. Entonces es -3. And here we have the focal diameter and the distance here is p, but here is 2p. 2p to p. Therefore, this point is a point, but in this case you move it vertical. Entonces you affect the second component, the y. So it would be -3,5. Why 5? Because it's 3 plus 2. P is 1, pero multiplied by 2 is 2. Entonces 3 plus 2 is 5, and 3 minus 2 is 1. Entonces that point is -3,1. Okay. Okay, entonces the only thing I need more is the centricity. Centricity, no. The directrix. Directrix is a line, guys. It's a line. In this case, is vertical line, no? And it's the same distance. It's the same distance of this. Same distance que p is 1. So it's p also. P is 1 in our case. See, this point is -4. It's obvious that directrix would be -5 because it's -4 minus 1. I'm moving to the left. To the left, yeah. And the axial symmetry is the horizontal line, que es y equals something, y equals 3, que es the, o sea, let me recall que my vertex is located at the point -4,3, que I do not erase, but I mix it together here, you don't see. This is the picture, rough sketch. However, I want that you are doing, using this our script, you make a copy and you attach with the test. Okay, it's easy. Let's do it. Let me share this over there. I suppose in that moment you see this, yes or no? Entonces, we are working the parabola. Parabola, P is equal 1. No, it's a coincidence. P equal, pero H and K no. H is negative 4. Negative 4. Negative 4. I type in using my keyboard or Desmos keyboard. It doesn't matter. K is 3. You can use this keyboard if you want. 3. Oh no, no 03, it's 3. And P1. And you select now. Remember, we have two kinds of parabola, vertical or horizontal. It's only horizontal. And arithmetic discrete, no. Okay, open to the right because P is positive. No, hyperbola. Hello. Parabola. Horizontal parabola. There you go. Look at that. There you go. Look at that. Vertex, negative 4,3. Focus, negative 3,3. Endpoint of the focal diameter, negative 3,5 and negative 3,1. Directrix is a line, x equal negative 5. Look at that, negative 5. And symmetry axis is the horizontal line, y equal 3. Look at that. Super cool. We are the best. Any question? You follow me?
Yes, sir.
Okay. Let's move on to the third question. Let me come back again to the whiteboard. No. Yeah. This is my whiteboard. Okay. Armida, Sandra. Hello. Okay. Don't say hello.
Yes, Professor.
Okay, cool. Feedback. Don't say anything. Feedback. Let me erase. Let's move on to the question 3. Do you see whiteboard or no? Yes or no?
Yes.
Yeah. Okay. Question 3 say x squared minus 4y squared plus 4x plus 32y 32y minus 64 equals 0. So I say it's obvious que hyperbola. How do you know que hyperbola? Because x squared exists and y squared exists both. And minus in between. I don't care. The coefficient is not important. It's totally irrelevant to identification. But important is que the x is positive. That means que our hyperbola look like that because the axis of the axis of not symmetry, the reference axis is parallel or coincidence with the x-axis. Okay, so now again we have the heavy algebra that I need to do in order to convert the general form to a standard. But it's okay. Let me try. You copy x squared. This is called, guys, transverse axis. Sometimes I forgot. I have a lack of maintenance. I forgot the name. Transversal axis. You grouping the x part and complete the square. And you copy the y part is this and this. Oh, but I saw the 4 is common factor because 32 is multiple of 4. But I factor out negative 4, parenthesis y squared minus 8y. Because negative times negative is positive, like the region. Plus another box. And in the right hand side, I'm moving 64 plus 2 boxes. Okay, this box is the box that can help me to keep equilibrium of the artificial number I introduce in the equation to complete the square, because I need the factors like a perfect square trinomial. So you take 4 divided by 2 and a square. 4 divided by 2 is 2 and 2 squared is 4. It's a coincidence. 4 is a nice number, gets the same. 4, 4. And you take 8 divided by 2, always divided by 2 and a square. 8 divided by 2 is 4 squared 16. This is 16. So our magic number can allow us convert this trinomial to perfect square trinomial is 4 and 16. Now the factorization, this trinomial is x plus 2 squared, and remember 2 comes from for the square root 4, minus 4, y minus 4, and 4 come from, because this is square root 16, is 4, equal, I forgot this number. This number is 4 and 64, minus 64, sorry. Why? This 4 is identical to this, because we have no factor to multiply. It's invisible one. But here we have factor -4 multiplied by 16 is -64. I like so much because 64 is cancelled out and stay alive 1 4. The last step is, in order to get 1 in the right hand side, you divide whole thing by 4. The equation in standard is x plus 2 is square over 4 minus y minus 4 square divided by 1, because 4 divided by 4 is 1, equal 1. This is my equation, nice, in standard. And guys, by the way, this is equivalent algebraically to this horrible original equation. It's the same. Suppose you put in decimals this, and you put in decimals this, and you get the same graph. It's equivalent. But now it's easy to see using the concept with the center, with the A and B, and this hyperbola. The center is located at the point center. At the point -4, 2. Now, center is -2, sorry. -2, get the H value, look at that, is these two, opposite side, 4. This is center. I plot back. So you plot, suppose roughly sketch by hand, -2, -2 is -1, -2, and 4 is 1, 2, 3, and 4. This is my center of the hyperbola. I know that the hyperbola open like that. But what is the distance? This is the center, and the distance here is A. Okay, and A is, well, I know that A squared is 4. Remember, the hyperbola, not necessarily A is the bigger. No, A is the positive. So my hyperbola is x minus h squared over a squared minus y minus k squared over b squared equal. So A always is the coefficient associated with the positive part. In this case, the positive part is x. That is the reason that the hyperbola is horizontal. Is the transversal axis. But the distance is A, and the distance is also A in both directions. In order to do the sketch of the hyperbola, we put B in that direction, okay, B is 1, B squared 1. In that direction, in that direction, in that direction, and in that direction. And you are doing a reference rectangle. Okay, reference rectangle, you're connecting by dotted line the corner, by the center, and you get the asymptote. Okay, immediately I want to write the equation. In order to complete the idea, we need to find C. But C squared is equal to A squared B squared. Guy, complete different equation. It's the same idea, similar, pero no igual. And the elixir is the bigger is a square, and the hyperbola, the bigger is c square. C is equal to square root 4 plus 1. It's square root 5. And the square root 5 is 2.something, 2.23, 23.6, 23.6, 236. I put 3 decimal place because decimals round off using 3 decimal place. 236. And this distance, the focal distance, is the distance from the center here. This is one focus, and this is another focus. This distance is C, and this distance is also C. And basically, from this point, you're adding radical 5. So actually, it would be minus 2 plus radical 5. And in another direction is minus 2 minus radical 5. And you obtain focal 1 and focal 2. Okay. Entonces, our hyperbola approximately passing through the vertex here, and it's asymptotically approached asymptotically to the asymptote. I forgot the equation of the asymptote. It's easy. The equation of the asymptote is y minus k is equal plus or minus, because you have two asymptotes, one is low positive, one is low negative, x minus h. In our specific example, y minus k, pero k is 4 minus 4. Is equal plus or minus b is 1. B is 1, a is 2, because it's square root 4. So 1/2, parenthesis, x plus 2, because h is negative 2. You plug it in the equation, double negative becomes positive. This is the equation. The positive indicate the asymptote can have a positive slope, and the negative is the asymptote can have negative slope. Positive, negative. Let's see clear now at that. Okay, let me try. Okay, here. Desmos, share. Okay, open now. Okay. In our example, A was 2. B was 1. Okay. H is negative 2. And K is positive 4. We are talking about horizontal hyperbola. Get the hyperbola whose the transversal axis is parallel to the x-axis. Something like that. Look at that. Repetition again. Center is the green point, negative 2,4. Vertex 0,4. That distance is 2. And 2 in another direction. And B in this direction, and B in this direction, and B in this direction, and B in this direction. And this is the acid. And this is my hyperbola, no? And you see it's totally asymptotically to the asymptote. Look, approach it, but never touch. Let me make it zoom. Never touch. Any question, guys? It's super easy or no? You're using this for doing your graph. And remember, I want to see, you have a rough idea in the piece of paper, no? You export the picture, you hell no here. Export the graphic. You set out the proper way. And you download. Any question? Everything is okay in the coding section. Entonces in the test we have, no, you have the test, no? You have the 3 questions. It's similar to this, different number, but it's similar. Switching to whiteboard. Let's move on to the sequences and summation. Okay, it's easy in my opinion, but sometimes I don't know why the student confusing a little bit. But don't worry, I clarify now. Okay, let me try. Yeah, there you go. Okay. Delete. Wait, too much. Okay. No. Let's move into the question 4. It's easy. It's easy. Question 4. Question 4 say, compute, find the sum of the sequence. And the sum is expressed in exponential notation. Sigma. K1 to 16. Oh, parenthesis, 2K plus 7. In this case, expand this is a little bit crazy because there's 16 elements. That's what I recommend. And the other no, but in this yes. Computer uses the formulas. So the formula is you separate this binomial into summation. Okay, that limit is the same from 1 to 16. And here you have 2K, but I do put the 2 outside and K stay inside summation, no? Plus 7. And 7 is a constant. So now I recall the formulas. We have this formula, a summation from K1 to M of K is equal N times N plus 1 divided by 2. In our case, N is 16. So 2 times multiplication, 16, and these 2 is out. 16 times 17 divided by 2. Do you understand where I come from 16 and 17? The 16 is M, and M plus 1 is 1 more, 17. You can cancel out these 2, why not? And multiplication. And when you multiply this guy, it's 272. Okay, I finish this part. Now let's move in this, que es easier. Another formula is sigma K1 to M. And when you have a constant C, I call in the lecture, get our C is 7, is 7 plus, actually this is 7 plus 7 plus 7, 16 times, is 16 times, it's a multiplication. So in our specific example, is 16 times 7, que 16 times 7 is 112. Now together is 384. Boom, that's it. Do you understand very well? Sure? Confusing? Clear? Say something. Are you there or you are leaving?
It's clear, Professor.
It's clear. Okay. Now, let's move on to question 5. Question 5 is similar. No, exactly. No. Question 5 is compute this summation. The summation from K3 to 5 of K squared minus 10. In this case, in my opinion, it's easier because it's too short. 3 to 5, we have only 3 terms. 3, 4, and 5. So you evaluate at 3. Entonces, the first guy is 3 squared minus 10. plus. The second guy is 4 squared minus 10. And the last guy is 5 squared minus 10. So you evaluate K vary 3, sorry, K equal 3. So this guy is for K equal 3. This guy is for K equal 4. And this guy is for K equal 5. Entonces, we apply this because it's short. But si it's long, no, it's crazy. Then you apply the formula, but it's okay. In this example, I prefer that way. It's doing. So now we have, this is 9. Minus 10 is negative 1. Plus, this is 16. Minus 10 is positive 6. And this is 25. Minus 10 is 15. So we have 15. 15 plus 5, because this and this together is 5, is 20. The answer is 20. That was easy, eh? Super cool, super easy, straightforward. So far, everyone get 100 in this test? So far? Yes or no? 100 or no?
Yes.
Yes, I suppose. Okay, number 6. Number 6, the questions say, okay, we suppose arithmetic sequence. Let's given the first guy, is A1, okay, it's negative 4. No, 0, no? Alright, it's 0, 0. No, negative 4, you are right, negative 4. Negative 4, so we are doing this. And D, que is a common difference, is 9, no? Okay, I know very well this formula. A sub m is equal to A1 plus n minus 1D. Okay, it's a formula que allows us to find the number in any position inside the sequence. When you have 2 pieces of information, we need the first, the original, the first, and the common difference. So A sub m is equal to negative 4.
He's on.
You say something?
Oh, no, sorry.
Okay. n minus 1 multiplied by 9. So we have negative 4 plus 9m minus 9. Entonces A sub m is equal to 9m minus 13. Boom! This is my formula. This formula generates, evaluate, plugging in 1, 2, 3, 4, 5, 6, 7, any number in the sequence. But then one specific 6. Okay, I try. That's easy. And 9 times 6, because I suppose n is 6 minus 13. It's a 54 minus 13 is 41. Boom! I finish the question 6. Important that formula, guys. Okay. Okay. Let's move with 7, que is similar, very, very similar. 7 is similar. It's the same, but a different number. It's arithmetic sequence also. But A1 is 0. Wow. And 0 is nothing, no? And D is fraction. Okay, no problem. A fraction is a number. I need to find A sub n. Yeah, I need to find A27. In the position 27. Again, we apply the formula. It's A1 plus A minus 1D. AM is equal to 0 plus n minus 1 times 1 over 10. 0 is 0. It's nothing. N minus 1 over 10. You can write like that. This is the formula to generate any element in the sequence. I put like that. Either way, if you write different, it's okay. You write like that, n minus 1 times 1 over 10 is equivalent. It's the same. You want to find the position 27. Plugging in 27n is 27 minus 1 over 10. 27 minus 1 is 26. And reducing lower third, divided by 2 is 13, divided by 2 is 5. This is the answer. This is 827 and 13 over 5. Are you clear in 6 and 7? Arithmetic sequence? All right, you see your face. Everything okay, guys?
Yeah.
Okay, nothing. Okay. Okay. Number 8 and 9 is different. 8 and 9 is different. There's also arithmetic sequence, but a summation. Okay, the number 8 is given. Let me see, number 8 is given what? 6 plus 12 plus 18 plus da. Remember, these 3 periods indicate that this continues forever, exactly the same pattern. Plus, and the last guy, okay, I don't know what's the length of this sequence, that maybe it's too long, I don't know, no idea. Is 480, I suppose it's long, and you need to find this one. Bam. What is the formula? Well, they are very different formulas. I want to explain in the traditional formula. So summation in the arithmetic sequence equal the first guy plus the last guy divided by 2 and multiplication by m. Oh, entonces es easy. The first guy is 6. The last guy is 480. Now you adding this plus this divided by 2. 6 plus 480 divided by 2. Oh, it's easy. No problem. But the problem is m, that you don't know, because you don't know exactly how many m times we have here. It's not explicit idea. But it's okay. We come back again to the formula that give me the position, no? Que es a sub n is equal a sub 1 plus a minus 1d. A sub n, I suppose que is the last one. A sub 1 is the first one. This is a minus 1, and the common difference, no idea. You subtracting this minus this, is 6. This minus this is 6. It's 6. It's a coincidence. It's 6. Doing some algebra. This is 6 plus 6n minus 6. Oh, nice. I like because 6 is cancelled. 0. And the answer is 480 equals 6m divided by 6 both sides. This will be the n is 80. Wow, too long. So this sequence contains 80 times. This is exactly the number that we need here to plug it in. 80. Actually, to compute easy, you got addition first. 486 times 40, no? What comes from 40? 40 is 80 divided by 2. And now calculator, the answer is 19,440. This is one possibility. Another possibility to compute this is not using this formula, no. Using the summation. Sigma for K1 to 80, because I know it's 80, look, under this conclusion, of the A sub m, que is 6n. I put 6k because the index variable in the summation is k. I call k. Entonces nada, es 6 outside summation from K1 to 80. Okay, and use it one more time. That formula, guys, is 6 times 80 times 81 divided by 2. Cancel out here is 3. It's 3 times 80 times 81. Let me try my calculator now. 3 times 80 is 240. 3 times 80 is 240. 240 times 81 is exactly the same as this answer. The test, not necessarily doing in both ways. Only one way is enough for me. So you see what the best way, in my opinion, is that one. It's more general. This is very particular, but it's okay. Do you understand very well number 8? I can erase? Okay. Delete. Okay, cool. Okay, number 9. Number 9 is a little bit weird. It's summation from N1 to 27 of the negative 4m minus 2, something like that. Entonces I realize que this is also arithmetic sequence. How do you know que es arithmetic sequence? Because this formula minus 4m minus 2 is linear. Linear means que the exponent is 1, no square, no cubic, que es non-linear. This is linear is arithmetic. So we can generate, for example, for n equal 1 is negative 4 minus 2 is negative 6, no? Comma, for n equal 2 is negative 8 is negative 10. For n equal 3 is negative 12 minus 2 is negative 14. And you can see that the common difference is D, que es negative 10 minus 6 is negative 4, negative 14 minus negative 4. Wow, it's arithmetic for sure. It's arithmetic. So we can use in this formula, que es A1 plus 8m divided by 2 multiplication by m is possible. Oh no, another students prefer doing like a summation, professor, using the formula for the summation. What do you consider better? Be honest. Doing by the summation or doing by a formula specific for the arithmetic sequence? What do you think? No opinion. Guys, you pay attention. I feel no good when you don't answer me. Mia left. Wow, Mia. Anthony is leaving, no? Anthony, you are leaving. Nathan, can you always answer me? Do you follow me?
Yes, sir.
Yes, sir.
Okay, cool. Okay. So no proposal. What is the best way? I do it by my way. My way is this. Bueno, A1 es obvio que es negative 6, ¿no? It's the first one. This is A1. Plugging in here. Minus 6 plus AM is 827. Because the last element in the summation is 27. So negative 4 times 27 minus 2. And this is negative, of course, 110. Entonces, actually is negative 6 plus, or actually minus, because plus and minus together is minus 110 divided by 2, and multiplication everything by 27. In this case, clear, it's totally explicit that M is the summation is 27. And the rest is put in the calculator in the story. It's negative 1,566 is the answer. Okay. No problema.
No hay.
Okay, cool. We did 8 and 9. Now 10 and 11, que es similar. 10 and 11 is similar. Es obvio que si you feel strong in the test, you don't need to wait till the Monday. So you anticipate and send me. So you feel strong. No? Okay, number 10 now. Number 10 is about geometry sequence, que es different. Now, what is given? It's given, let me see, I don't remember. It's given A, actually it's A1, it's 4, and the common ratio is 1/3. Okay. They want to know A sub M, one more time. And summation, no, summation no. A to the fifth, o sea, to the, and the position 5. Let me read again. This find the fifth term. No, actually fifth. Well, okay. Okay. So now the formula for the geometry. This is geometric. How do you know? Because the question says get geometric. Geometric sequence. And the formula for the geometric sequence A sub n is equal A1 multiplication R n minus 1. It's a formula. A sub n then is equal A1 get 4 times R, okay, R is 1/3, sorry. 1/3 raised to the n minus 1. And that's it. I suppose can not necessarily do any more. That's enough. This is the formula. You want to find the position 5. It's 4 times 1/3, and you plug it in substitution M for 5. 5 minus 1 is 4. This is 4 times 1 to the 4 and 3 to the 4. 1 to the 4 always is 1. This is 4 in the top, 81 in the bottom. 3 times 3 times 3, 4 times is 81. It is. This is the element in the position 5. Okay, now 11 is similar, very, very similar. But the problem of the 11 is that A1 this was 10 and this is 11. A1 is equal -2 and R is equal -5. Okay. It's 2. Same formula, that formula. A sub m is equal -2, parentheses, -5, and -1. It's perfect. Leave it like that. Now specific to the fifth power. Yeah, it's -2, -5, raised to the 5 minus 1 get 4. Oh god, okay. So A to the fifth power is -2 times -5 to the fourth power is 5 times 5 times 5 and times 5. 5 times 5 is 25, 25 times 20 is 25, it's 625, pero positive, because the exponent is multiplication by 2 is minus, of course, 1,250. Done. 10 and 11. Okay. I suppose we are doing well. I suppose we finish maybe today. I suppose, I don't know. Okay, now we finish that page. We move it to the last page. So that page is gone. Don't move it to this. Let me make it soon to see more clear. So you compute sum. Entonces 12 is summation from K1 to 5, 2 or 3, and 2 to the K power. So it looks like similar to the geometric series, geometric sequence, summation for the geometric sequence. This is the formula for the summation of the geometric sequence is A1, parenthesis 1 minus R to the n power divided by 1 minus R. This is the formula for the geometric sequence, summation of the first n term, in this case 5. But it's okay. I need identification who is A1 and who is R. Let me try to do my best. You evaluate at K equal 1. Entonces, 2/3 plugging in K1 here times 2. Raised to the 1 power, que es invisible, no? Actually, entonces 4/3. 4/3. This is the first. This is actually is A1. This is this. The second is 2/3 parenthesis 2 to the second power. Okay, 2 to the second power is 4 times 2 is A/3. So it's A/3. Enough. A/3. You divide this divided by this. It's the common ratio. A divided by 3 divided by 4/3. It's A divided by 3 times reciprocal get 3/4. 3 is cancelled, and A divided by 4 is 2. So I have in my hand the information that we need. It's A1 is 4/3 and common ratio R is 2. Now I come back with this information into this formula. Okay, I find the summation, but the summation only 5 because this is 5. Entonces es A1 get 4/3 fraction, another fraction, 1 minus 2 to the 5th power, because n is 5, 1 minus 2. Okay. Easy. 4/3. 2 to the 5th power is 32. Positive. No, negative. Plus 1 is negative 31. And 1 minus 2 is negative 1. And negative divided by negative is positive. So the answer is 4 times 31 divided by 3 is 124 divided by 3. It's the answer. So the central idea in this problem is that formula. And to determine that formula, you expand a little bit the two first elements and the sequence. Of course, this guy is A1 and this is A2. But A2 divided by A1 is R. Okay. Number 13 is exactly the same. I suppose que sí, sir. Let me try. Is 13. Compute the summation from K equal 1 to 4 of 1/2 raised to the k plus 1. At the beginning, I don't know who is A1 and who is R, but don't worry. Yo evalué. Suppose k equal 1, que es the inicio. Entonces, 1/2 raised to the 1 plus 1, que es 2. And it's a 1 over 4. So because 1 over 4. This is A1. A2 is 1/2 raised to the cube backward. Because it's 2 plus 1 is 3. 1 over 8 is 8. I'm going to find the common ratio. You divide A2 divided by A1 is 1 over 8 divided by 1 over 4 is 1 over 8 times 4 over 1 is so big that 4 over 8 gets 1/2. Conclusion, the first one, I have R is positive 1/2. Plugging in the formula. The formula says summation, but in this case 4 elements because the upper limit is 4. Entonces A1 is 1 over 4. Another fraction, 1 minus 1/2 raised to the 4th power, 1 minus 1/2. Okay. Let's do in the exponent first, or the operation. This is 1/4, stay the same. This is 1 minus 1 over 16, because 1 to the 4th power is over 1, and 2 to the 4th power is 16. And 1 minus 1/2 is 1/2. Okay, now subtraction. 1 over 4, this is 16 over 16, is 1, minus 1 over 16. And 1/2 here. And 16 minus 1 is 15. Is 15. 15, 15, 15. So it's 1 over 4. I continue working. 15 over 16 divided by 1/2. Okay. Let me divide the upper part first. So it says 15 over 16 times 2 over 1. Flip it, reciprocal this. Okay, so we get 15 over 8. Because cancel out, divided by 2, 1, divided by 2, 8. Now 15 over 8 is the answer of this part. Multiplication by 1 over 4. So 1 over 4 times 15 over 8, super easy. The multiplication of the fraction is the Easter operation. You multiply numerator, numerator, denominator, denominator is 15 over 32. It's the final answer. Any question? No? Okay. Where's the next? Well, the next is super easy. It's about series. Remember, series is summation, but series is summation when the limit is infinity. So infinity element. So we have 5 minus 5 over 3 plus 5 over 9. I suppose it's minus because alternating plus minus plus minus plus minus and this is infinity. Infinity summation. And remember, the only possibility for the series to be divergent is when the common ratio actual value is less than 1. Otherwise, no. There's another, so 2 conditions to be convergent. Number 1, to be geometric series. And number 2, in the family of the geometric series, the common ratio is less than 1. Okay. Otherwise, no. Otherwise, diverges. That's the answer. So now, I know, I analyze in this sequence, A1 is 5, and A2 is minus 5/3. Therefore, the common ratio is 5 over 3 divided by 5. And negative 5 over 3 times 1/5. The 5 is cancelled, and the answer is negative 1/3. Let me try to prove the condition. Absolute value, negative 1/3, is less than 1. Yes, it's true. Now the confirmation is yes, this series is convergent because it's geometric and the common ratio is less than 1. The actual value. Now, at what value converge? Is the second question. The formula is A1, 1 minus R. It's easier. The formula is easier than it. Entonces es A1 is 5. And common ratio is negative 1/3. Be careful because we have double minus. It's 1 minus 1/3 is plus 1/3. Okay, the formula have a minus, however, the common ratio is negative, together is positive. Now you adding 1 is 3 over 3 plus 1/3, entonces 5 over 4 over 3, because 3 plus 1 is 4. Now division. Division, you copy the first, and you multiply by reciprocal, 3, 4, that's 15 over 4. I know it's 15 over 4, yes. 15 over 4. This is the answer for the 14, no? Well, let me see. Yes, 14. And 15 is really a stupid question because 15, let me try to do, but a super stupid question because it's 13 plus 17 plus 19 plus 21 plus it's infinity sequence, but it's so because divergent because actually it's not geometric. When you divide 17 divided by 13, it's not equal 19 over 17, que es the second division. So no common ratio, no geometric, no satisfy this condition. Entonces the answer is divergent. Okay. Do you understand very well this or not? So to be convergent is very weird. Two conditions. Condition number one is que es geometric. Okay, pero this is not enough. Es necesario, pero no enough. O sea, es geometric, okay? Are you verify the common ratio? The common ratio is less than 1. Oh, yes. Entonces, now together imply que es convergent. It's convergent. They put here divergent. I'm crazy. Okay. I make a mistake. This is not divergent, it's convergent. Convergent. Okay, summarize. The only possibility when you take calculus, no. Pero en pre-calculus is this. The only possibility to be convergent is, number one, to be geometry series, and the common ratio when you investigate is less than 1. I promise, in calculus 2, we see another series is also convergent, more complicated, but in pre-calculus only that. Okay. Okay, then we have one example of the mathematical induction. Okay, it's easy, but it's weird, you know, it's confusing. The students don't understand very well at the beginning. So I need to prove using the method of the mathematical induction que 2 plus 5 plus 8 plus plus 3n minus 1, que es, I suppose, the subenter, is equal n over 2 multiplication by 3n plus 1. I remember the mathematical induction principle. You prove statement 1 is true. Statement 1 is when the n is equal 1. And n equal 1, I suppose is this guy. It's 2. And the rest no, because it's 3, 2, 3, 4, 5. And you're plugging in n equal 1 here. This is 1/2 3 times 1 plus 1. 3 times 1 is 3. 3 plus 1 is 4. And 4 divided by 2 is 2. So it's true. 2 equal 2 is true. Okay. Okay. Now, so you try n equal 2. You see que again it's true. Pero you need to apply infinity, que it's impossible to do it better. So you suppose que one arbitrary position k in the middle, S sub k is true. This is supposition. And this is super easy because this is equivalent to write 2 plus 5 plus 8 plus pa. Don't finish to m, you finish to the k. And k is 3k minus 1. Should be equal k over 2, 3k plus 1. Yeah, I assume that this idea is true. If using this equation or using this equation, if you prove s sub k plus 1 is also true, so now that propagate is true forever to infinity. And you'll finish the proof. So what you simulate k plus 1? Well, it's the next. So 2 plus 5 plus 8 plus plus I bring down this 3k minus 1. You include 1 extra, que es k plus 1. So you replace mentally k for k plus 1. Entonces 3k plus 1 minus 1. This is in the left hand side. And the right hand side similar. You replace k plus 1. Entonces k plus 1, 3k plus 1 plus 1 over 3 over 2. Is this 2. Now the only thing I did was in any place when you attach 1 extra addition k plus 1. But in the right hand side you replace k for k plus 1. It's logical, no? Because it's the next. Okay, let me try. Entonces 2 plus 5 plus 8 plus plus 3k minus 1 plus, entonces you apply here, bueno, distributive property, dice 3k plus 3, 3k plus 3 minus 1. Entonces 3k plus 2, because 3 minus 1 is 2. Okay. Here, similar. It's k plus 1. And this again, distributive property is 3k plus 3 plus 1 is 4. It's 3k plus 4. Okay. We almost finished. Now, remember the strong supposition. It was this. So si this is true, it's because that part is equivalent to say k over 2, 3k plus 1, plus 3k plus 2. Okay. Equal something I don't want to write now. No, I don't. Now, why not? Put together. Put in one common denominator, 2. So we have k, 3k plus 1, plus 2 times 3k plus 2. Okay, what more? Well, no idea. You apply distributive maybe. 3k squared plus k plus 6k, this and this plus 4 divided by 2. Entonces you combine that term, 3k squared plus 7k plus 4 over 2. Okay, I will stop here. I need to continue, but on the right-hand side. At the right-hand side, you have two binomials, and you FOIL this binomial. You multiply FOIL first, 3k squared, plus 4k, sorry, 4k, plus 3k, okay, this and this, plus 4. Don't forget, divide by 2, that's this 2. And you combine, like term, is 3k squared, plus 7k, plus 4, divided by 2. Wow, at this moment I realize this expression is identical of this. Now I prove. Okay, this original problem is true for all real numbers, or natural numbers. Doesn't matter, get 1, 2, 3, 4, 5, 20, 300, 3 million. It's true. By mathematical English. Induction. Guys, do you understand this or no? You can do that in a specific example in the test. It's the same routine. I don't want to change too much. Any question? Come on. That was, what number is? 16, no? 16? 16. Yeah, that was 16. Mathematical induction, only one question of this. Okay, let's move on to the binomial theorem. And the binomial theorem that we studied, but too fast last class. I want to reinforce the idea today. Okay, look. We have too easy and too complicated. What is the idea? The idea is 17. Look at that 17. You need to expand. Expand parentheses 2x plus 3 raised to the 5th power. Expand. I know when I finish, I have 6 terms. Why 6? Because it's 0, 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5, and 6, including 0. Okay? Entonces now, according to the formula, bueno, the formula is, let me recall quickly the Pascal triangle. The Pascal is 1, 1, 2, 1. 1, 3, 3, 1. 1, 4, 6, 4, 1. And 1, 5, 10, 10, 5, 1. This is the thing I want. It's n equal 5. Now the coefficients are 1, 5, 10, 10, 5, and 1. However, the variable is easier because you consider it, for example, in the formula that I explained last class, this is A and this is B. Okay, entonces the first guy, coefficient is 1. Look at that. Coefficient is 1. I write 1. This one is this. And it's a 2x to the 5th power. Plus the second is 5. We navigate here, 5. And we have 2x to the 4th power. You decreasing A, 5, 4, 3, and so on. B increasing. Times 3 to the 1. So you check it out, see if we are doing well. See the sum, 4 plus 1 is also 5. Again, 5 plus 0, because B do not exist, is 5. 4 plus 1 is 5. What is the next? Well, the next is 10. So it's 2 x to the 4th power. Let me try now. This is not correct. This is 4th power outside. It's a 4 power outside, include 2. This is 2x to the third power and 3 to the second. Do you follow me? 3 plus 2 is 5. Plus, I did that, now 10 again. 10 again. 2x to the second power times 3 to the cubic power. 2 plus 3. What is the next? The next is 5. Too long, guys, sorry. Is 2x to the 1 power, invisible. 2 minus 1 is 1. No, 1 is invisible. If you want, put it on all. Invisible. And 3 to the 4 power. And we have one more, because this coefficient is 1. Que es 3 to the 5th power. The rest is easy. The rest is, you put in the calculator here, to the 5th power is 32. X to the 5th power. Plus, you put in the calculator, 2 to the 4th power is 16. 16 times 5 is 80. And 80 times 3 is 240. 240. Do you understand where I come from 240? What's the multiplication? 5 times 2 to the 4th power times 3 to the 1 power. This is 5 times 16 times 3. 240 x to the 4th power, the variable is to the 4th power, plus likewise, it's a 2 to the cube is 8, times 10 is 80, times 9 is 720. X cubic plus. This is 2 to the 4th power is 4. 4 multiplied by 27 multiplied by 10 is 1080. You can verify in your own calculator. X squared is the variable. Plus 5 times 2 is 10. And 10 times 81, because 3 to the 4th power is 81. Is 810. X plus 243, que is 3 to the 5th power. And this is my beautiful final answer. When you expand. Guys, do you understand very well or no?
Yeah.
Sure?
Mm-hmm.
What do you say? Yes.
Really?
Go ahead.
No, singer.
No question.
Nope.
Okay. Remember, we are using that formula. The formula of the Newton binomial is sigma from K0. Okay, this is K0, by the way, no? K1, K2, K3, K4, and K5. In total, we have 6 terms. To M, que N in our example 5, okay. And you realize, for example, in our example, M is 5, 5th power, A is 2x, and B is 3. And you plug it in. Entonces now, the typical example is the Pascal number, que es NKE. This is Pascal number. I put no complicated, I put easy. 5, 6, no more than this. A to the n minus k, pk. And you see how, when the k increasing, the exponent of the a, okay, in our example is 2x, decreasing. 5, 4, 3, 2, 1, 0. And the b increasing is 0, 1, 2, 3, 4, and 5. Cool, nice. Okay, let's move into 20. 20, and I suppose que 20 is the last one for today. 20 is easy. 20 is X, no, W, sorry, 18. It's 18, sorry, 18. That was 17. 18 is W minus S to the 6th power. Entonces, this is confusing, professor, because you explain when it's positive. But what happens when it's negative? It's the same. But the only consideration que M6, A es W, but B es minus S. Entonces, en any B, in the formula you put minus S. Happen que when the exponent of the B is even, it's positive. But when the exponent is odd, it's negative. That's it. And this is easy because it's 6 power. No, it's not easy. Hello, it's too long. We have 7 terms. The first one is obvious. Wait. I come back to complete the Pascal. And the Pascal is 1, 6, 15, 20, 15, 6, and 1. That's the coefficients. Remember, you obtain that coefficient adding this. Always adding this. So 1 plus 5 is 6, 5 plus 10 is 15, 10 plus 10 is 20, 10 plus 5, and this is symmetric. We have the big number in the middle, and this is coefficient, and this coefficient is the same. So now the expansion of this binomial would be W6 no S plus 6 times, look at that, W5 decreasing and minus S to the 1 power. For a moment, leave it like that. After we align of clearance. The next is 15. The next coefficient is W4 and minus X squared. Don't forget to double check it. 4 plus 2 is 6, 5 plus 1 is 6, and 6 plus 0 is 6. What's the next? The next is 20. 20 W3 minus X cubic. 3 plus 3 is 6. Let me continue, but down. Because it's too long. What is the next? The next is 15 again. It's 15, W4, and minus S to the 2nd power. I did that. 6 plus 6, W5. No, not 5th. Is, I make a mistake here. This is 6, 5, 4, 3. This is 2. 2. It's obvious that this is 1, and 1 is invisible exponent. This is just W. This is minus X. Okay, and the exponent here increasing. This is 1, this is 2, this is 3. This is wrong again. It's 4. That's 4. And this is minus X to the 5th power. It's 1 plus 5. And the last guy is 1. Minus S to the 6th power. Entonces, I finished, but I put more elegant. More elegant means que you put W6. And this is minus 6 times WS. Because negative X to the 1st power, when the exponent is odd number, is negative. However, when the exponent is even number, it becomes positive. And the next guy is 15 W4. Alright, this is 5. Sorry. 5. This is 4. And this is X squared positive. Because negative 1 is squared positive 1. This is alternating. You see, when you have sign negative here, the first guy is positive, the second is negative, the third positive, the next is negative. Negative what? Negative 20 W3 X cubic. Next is positive because of 15 W squared X to the 4th power. The next is negative, negative 6 W X to the 5th power. And the last one is positive because the exponent is even. Entonces, X to the 6th power. This is my final answer. 1, 2, 3, 4, 5, 6, 7. It's expecting 7. Wow. Well, we have time to do at least one more. What do you think? It's good to do one more? No, no two. We need 19 and 20. We left to the Monday or no? Opinion, guys. Are you tired? Nathan, what do you think? Patrick, what do you think? Anaí, Armida, Alberto. Alberto! Do you hear me, Alberto? Alberto? Oh, Alberto Abreu. I want to talk to you. Maybe I call by phone, no? Okay, guys, no opinion. We finish. Okay, we finish.
Finish, Professor.
Armida, what do you consider? What is your opinion?
I need more practice, to be honest.
No, of course. The practice, Armida. Yeah, the practice is doing the homework. So, the conception, my conception of the classes, you practice doing the homework. When you stop in the homework, you send me a screenshot. I try to explain. Okay, this is like,
Thank you.
okay, so we continue Monday, guys. It's the last day. Okay, bye-bye. Have a nice day.
Good night, Professor. Feel better.